Hey folks, Phil Zito here. Welcome to Smart Buildings Academy TV episode 20. Good to see you all in here today. So we're going to be going through sequenced control. I'm going to take us over to the whiteboard. We're not even going to spend any time here looking at this monitor. We're going to go over here to the whiteboard. We're going to talk through sequence control. So how's everyone doing today? Hopefully doing well. Apologize for missing Monday night's live stream, but had some family stuff going on that I had to take care of. So sequenced control. This is something we're going to be using to do like DX cooling. This is something we're going to be using if we're staging up multiple devices, like staging up chillers, staging up fans on a fan wall, etc. So sequenced control, how it's going to work is we're going to typically have like a PID block. And I know, once again, we haven't covered PID blocks in great detail. By the way, everyone, I did a new sound thing, so in comments, go and tell me if sound is good. It should be good. I tested it before, but I just want to make sure it's coming through good to you. So just post in comments, say sound is good. All right, so as I mentioned, we're going to do a PID loop now. We'll cover PID loops in the very next video. I realize we haven't covered it for some of y'all, but we're going to have a process variable and set point, right? Our standard 2 points that we go into a PID loop with. And then we're going to have our output, and our output is going to go. And there's multiple ways this can happen, right? With a sequencer, we can do things where we are doing, actually, let me check one thing real quick. Make sure I got that turned. Okay, yeah, it's turned on. Cool. I started getting up at 4:30 in the morning lately, and that's got me all out of whack. Just like all out of whack because it's messed with everything. So as I mentioned, process variable set point goes into a PID block, and that's going to go into, depending on your software, sometimes you'll have like a pre-sequencer block that will go and regulate which stages you're in. Sometimes you'll have it's like a step performer block. And in other stuff, you'll just have a straight sequencer block. Some of these, you won't even have a PID block. But basically what we want to do is process variable set point, and then you've got your sequencer block, right? So SEQ. And then this SEQ is going to have multiple different points, and we're going to see this when we look at the control system itself. But it's going to have like interstage delays. It's going to have minimum on-off times. And then you'll have either a linear sequencer, which will just basically divide that 0 to 100% signal by however many stages you say you have. And then for each stage, it'll be like 5% below that for it to go off, 5% above it for it to go on. And so then from the sequencer, we will go and we'll have on-off to our BOs. So like BO1, BO2, BO3. And imagine out in the field that these are RIB U1Cs connecting to chiller enable signals. Or these are IDEX energizing contacts on our DX cooling stages, etc. So we will go and we'll have our on-off commands, our Boolean commands. And this sequencer is just going to step it up and it's going to step it down. So it's also called step control. It's called staged control. And it's called sequenced control. So if we're going in our hierarchies of control so far, we started off with on-off, which is a common control mode that we've seen so far used in everything, right? We've seen on-off used in on-off control, obviously, in our floating control, and we've seen on-off control used in our sequenced control. So we've seen it used across the board here. And now we are going to go and we're going to take a look at the computer. We're going to look at some applications. I'm going to move us over there real quick. All right, so let me switch over the screen real quick. Give me a second. Transition us over here. And you should now be seeing my screen. Okay, good. So I'm going to go in here and we're just going to look at a basic linear sequencer, right? This one's 3-stage. We're going to make it 2 stages. Okay. And then what we should see, so we got 2 stages right here. I'm just going to grab a ramp utility that's going to simulate a value. And I'm just going to route it here to the input. And we should start to see these stages enable and disable. So we'll see like stage 1 go on. And we're not going to see stage 2 go on because we're not going to exceed that value for a certain amount of time. So we can set our range right here with this in, max, and min. If I like go here, set this to 50, we're going to see it has a different effect now. And we should start to see output B come on. So I can kind of set my range. I could throttle my range right here. You can see that I could do that. I can do my delays if I wanted to. I could create delays. Like I could go and create a 5-minute delay right now. So you can see there's an off delay, there's an on delay. You can start to see kind of how I'm doing this. Hopefully this makes sense. It's pretty straightforward. So if I bring up the super highly advanced application of Microsoft Paint, we're going bleeding edge here, folks. This is super highly advanced. But if we look at our 0 to 100, right? And like I said, I set that to 0 to 50 just to simulate here, but 0 to 100. And then when we step above that 100, or we're at that 100, actually we'd usually set it like I did, 0 to 50 or 0 to 75, something like that. When we step above that, we're going to invoke right here our on delay. And we're going to invoke our off delay as well. So we'll have a delay for our on, and we'll have a delay for our off. And the off delay is obviously going to take effect on the downward, and the on delay is going to take effect on the upward. So as we step up to needing more demand. And the reason for that is to prevent short cycling of devices. You don't want devices slamming on, off. We can set multiple different rotation types, but we're not going to do that because we want this to be just a straight up linear on, off, and we want it to activate the same things. This is how you would do DX cooling. Now, if you had like a chiller, if you had 2 chillers, you could do rotating, and you could rotate between chillers to optimize runtime, things like that. There's more advanced versions of this kind of block right here. You could create your own blocks or get access to libraries that have runtime built into them. And this will look a little different depending on what manufacturer you're working with. But going and implementing sequence control, definitely something you should really learn. Like always, I recommend whenever you are learning any logic blocks, go into your help, go and read about the block. So sequence linear, so we would just type in here, sequence. Let's see if I could spell today. It's been a long day. Right? And we would go here and we dig into this and we would learn how the block works. And once we learn how this block works, right, then we go and figure out what we want to do with it. We learn how it calculates its on off. We learn what these different variables for the block do. And that's how you learn to set it up. So if you're learning, if you're here, if you're watching this, you're new to programming, you're new to controls, whenever you go to any software, as long as you understand what you're trying to accomplish, then it's just a matter of finding the block, reading the help, and applying the block. So for example, we know that with a DX cooling, we're going to want to stage on compressor 1 and then stage on compressor 2, and we want to stage them off in the reverse order. We don't want to do rotating like we would do with a chiller. So we're going to want to find the appropriate block that lets us stage sequentially. If we have 2 like-sized chillers and we want to rotate them for runtime, then we want to find the block that allows us to do that. And then we know that with any form of sequence control, we have minimum on and off times, and we have minimum run times as well. So since we know that, right, and we have interstage delays as well. Since we know that we just have to go and look for the appropriate variables so we can go and set up the blocks accordingly. That's kind of the secret to programming. Whenever you look at logic and you're trying to figure out, like, shit, how do I program the sequence? What do I do? Well, you start to go and you look for keywords, like if it says stage or multiple stages, like electric heat, DX, you start to learn that these things, okay, this is linear staging and I don't want to rotate it. And then you see things like chillers, boilers, etc. And you're like, oh, okay, this is usually going to be runtime rotating, and I'm going to want to rotate those using runtime. So once you learn these little nuances, piecing together the programs is not too difficult. All right, I'm going to take any questions you have about sequenced control. Next Monday, we are going to be doing PID control. I've had a lot of requests from people who are in Europe and people who are in different parts of the world asking us to do a different time for Wednesdays. So going forward, Wednesdays is actually going to be at noon, and Mondays will continue to be at 8 p.m. So Wednesdays will be at noon. So for those of you who are watching this replay, and I'm getting those messages from you saying, Phil, I love the SBA TV, but I can never watch it because I'm in Europe, and right now it's 3 o'clock in the morning, and that just doesn't work. So don't worry, Wednesdays, you'll be able to do that. And then Mondays, obviously, we'll have the same time of 8 p.m. But this is the time when you ask whatever questions you have, whatever you want to learn about, anything I can help you with related to this topic, ideally, feel free to ask. If you haven't yet, I encourage you, go and check out our podcast on why I think BACNET SC is a terrible idea. I think you'll enjoy that. It gives some education around what BACNET SC is and helps people better understand what that is, how it's, why it's being used, and probably not the best name for a podcast that I was trying to keep kind of neutral. But, I mean, if you've followed me for any amount of time, you know I don't really like BACNET SC. I think it's a bad idea. But that's neither here nor there. So, that being said, I will remain around for a couple minutes. It's so awesome to see so many of you here. We've been in the double digits consistently now on viewers. That's awesome that you all are spending your time with me. Thank you so much. I really hope I'm delivering value to you. As I said before, continue to give us feedback on ideas. Coming up on SBA TV, we're going to be getting PID loops next Monday, and then we're going to start diving deep into networking. We're going to start with physical network architecture. Then from there, we're going to go to data links. So we're talking Ethernet, MAC address stuff, ARP tables. And then we're going to go from there into IP. We're going to look at routes, subnets, subnet masks, VLANs, etc. Then from there, we're going to dive conveniently into BACNET. And we're going to talk about BACNET's parts 1 through 3. Then from there, I'm taking a 2-week hiatus. We may do SBA TV, but I'm going to be traveling to North Carolina. I don't know if the wife's going to let me do that. So, hey, Bruce. Hey, James. I see you all in chat. Good seeing you. Awesome that you all are here again. Thanks so much. I think what we'll do after BACNET will probably be some form of programming. All right. Bruce asks a very pertinent question since he's in Texas, and they're having a little bit of a heating issue right now. Can this type of staging be used for boiler systems 3+? It depends. So there are a couple different versions of boiler control. Let me bring something up real quick. I just got to move some stuff around. Let me change that over to there, transition here, and let me log into our LMS. Excuse me. Let me clear my throat here. We got too many courses. Control sequence fundamentals. Okay. Let's go to Scrolling. Oh, passed it. Hot water multiple boiler control. Is that the one I wanted to show you all? Let's take a look. Okay, I'm going to mute this just so it doesn't blast. All right. Let's switch us over to 2x speed. Ah, there it is. So there's 3 control modes for boilers. Unison control. This is for like-sized boilers, right? These boilers are all the same size. You can control them in unison. Let me see if I can bring up unison control, right? Multiple boilers, same time, same fire rate, assuming that they're the same size, same flow rate, so same BTU tonnage on these, okay? Then we have... did I pass? Ah, I did pass it. I went too quickly. Hold on here. Staged control. This is where we use multiple boilers and we stage them up. This is where you would use the sequencer block, Bruce, is under staged control, right? So as the supply temp drops, we're going to stage those up. And we're going to, ideally they're running in low fire and we just bring them out of low fire and we kick them up. That way their circ loops are preheated and we don't have to worry about shocking them. All right, and then you have, lead lag control. All righty. J-Cell has a question. Once you have wind up on a PID loop, how do you get rid of it? Or is there something in programming that you add so it doesn't have wind up? I'm missing that. Great question, J-Cell. So, wind up. It depends on the software. But let me grab... Sorry, my eyes are going at my old age. I'm not even that old. And you notice how big my mouse pointer is? This is pathetic. I said to myself, holy crap, Phil, you're not even 40 yet. And you have to go into ease of use and set a bigger mouse cursor and make it black so you can see it. Because, yeah, I'm getting old. Gosh, man, my eyes are going. It's because I stare at these bright screens all day long. All right, so you want to go in here and you want to find this action. Now, this is Niagara. There's other software, but I'm just going to show you Niagara because we have Niagara open. We tend to teach Niagara just because of its market share and the simple fact that Honeywell and Tritium were some of the first companies to support us from a materials perspective and letting us resell their software and resell their hardware to our students. So we tend to teach this stuff. And I mean, it's got a very large market share. No matter where you go, you can find some form of tritium. So right here, what will happen? Let me blow out this ramp real quick. Control delete. Bring you over here to our control variable. Let me add a numeric writable. Okay, I'm going to set this to 1. We're going to go and output it to there. Loops enabled, right? We've got our control variable, and our set point is 1. Okay, so we're over our set point. We can see kind of what's going on here. I'm going to go in here, and I got to put in some sort of proportional constant. I'm going to put in 25. Okay. There we go. Now, J-Cell, what you'll notice here, I'm not getting any wind up right now. Why do you think I'm not getting any wind up? I would let you answer it, but there's so much delay in YouTube Live, unfortunately, that I'm going to answer it for you. The reason why you're not getting wind up is this is proportional only. So what I find a lot of folks make a mistake on, and it's something we teach very heavily in our PID loop tuning course, is that people mistake the PID loop equation. Proportional times error equals output in a proportional only loop, and you will not have buildup because proportional does not have a logging effect, meaning that proportional, each time you see a tick here, that is a process loop. The equation is running. So each time that equation runs with integral, that value remains. So you have accumulated I. So until you get below 0 on your error, you will not start to decumulate I, which is integral. But with proportional, you don't have that problem. So proportional is going to accumulate, but it's not going to stay accumulated. That value, give me one second, I take a sip of water. Woohoo! I was thirsty. That accumulated value is not going to remain. Okay? So as you go back to 0 error, you're going to lose all that proportional response. That is not the case with I. Now I'm going to add some I in here. Okay? I'm going to add a like crazy ass I value here of 10. That's insane, right? And we're going to see that when you look at this output almost never goes below 100. Almost never. You might get a minor dip when it gets down to like the very end of the ramp, but there's so much accumulated I right here that it's a problem. So there's 2 ways you can clear this out. In some software, you can go and disable the PID loop. The other one is to invoke the reset integral action. So what I'm going to do here, I'm going to go in here and delete my I, right? So I've deleted my I, but I have so much accumulated I that it doesn't matter. You saw it dip a little bit there. I'm starting to put a dent in that I, just a little bit. Now if I go here and I reset this integral, I actually have my proportional band set too high too. I'm going to set it to 1 just to make this simpler. If I go and reset my integral, it will actually go and clear out all of that accumulated I, and it will start to clear it out. I can't zoom in any more than I've zoomed in, unfortunately. That's like as big as I can make it. It's as big as it'll let it go. If you're like me and got old eyes, I know it's kind of hard. But that is how you flush out that wind up. Is you either find a way to reset integral, you clear out the I and you let it run through, you reset the loop. It just depends on your manufacturer. But that's how all that stuff works. That makes sense, JCell? Hopefully it does. Whew, someone's got the heat on in this house. Holy moly, it feels like an oven in here. That, and I have so many lights on in here right now. It's insane. All right. Let's switch over again. Okie dokie. What other questions can I answer for you all? Wind up and wind down are the same speed? Yes. Yes, they are, because they are both influenced by the integral value. Because remember, the equation is output equals P times error, proportional band times error, plus, and this is in brackets, now we're doing all that PEMDAS stuff, right? So this is in brackets, integral accumulated plus integral times error. So that integral accumulated gets added to by that integral times error value each time the process loop runs. So if you've got a negative error because you're using a direct acting loop and you're below set process variable, below set point, then you are going to go and you're going to see a deductive wind down. And you can actually have wind down where you're below process variable for so long, below set point for so long, that you actually wind down the loop and you have negative accumulated integral. Once again, take this with a grain of salt. It all depends on the equation. that your manufacturer uses. Some manufacturers use time-based I and derivative values. Some use numeric derivative and time and integral values. Others use self-tuning loops. So, I mean, it's all over the place. There's no rhyme or reason, unfortunately, to exactly how they want to do things. Alrighty. See if there's any more questions. For those of you who want to dig deeper, we'll encourage you to check out our PID loop tuning course, which I'll link to in the chat. That being said, stick around here for a couple minutes, see if there's any questions, see who I have pissed off around BACNET SC. Because I dropped a bomb on LinkedIn and Facebook and the podcast today saying that BACNET Secure Connect is a horrible idea. And as you can imagine, that made a lot of people unhappy because they've put a lot of time into developing that protocol. And I just think it's bad for the industry. And I'm not going to support something I don't believe in. So, even if it doesn't make me friends, even if, unfortunately, it'll probably cause my business to lose some business because it's going to upset some of the OEMs, most likely. But I'm not going to go and preach to any of you all on something that I don't believe in. You all who have been following me for any amount of time know I'm always going to tell you the truth of what I think. I'm never going to try to promote something I don't believe in. And I'm definitely not going to sit idly by while all these people are out there acting like BACNET Secure Connect is like manna from the heavens descending upon us, and just sit there and be like, oh yeah, I agree too, because I'm just going to say whatever you want me to say so that I can have your business. No, I'm not going to do that because that's just not right. Anyways, you didn't join to hear me rant about that. Maybe some other time. So you don't like BACNET SC and you're going to talk about it when I got to hear this rant. Yeah, kind of, sort of, maybe. If you want to hear more, there's 30 minutes of me ranting about BACNET SC in our latest podcast episode. That's either going to be very well listened to or probably one of our least listened to episodes. One of the two. What is the gist of what I'm talking about with BACNET SC? Okay, so here's the deal. Oh, you asked, so I shall answer. All right, so here's the deal. BACNET SC, BACNET Secure Connect, is a way of securing BACNET. So BACNET IP and MSTP are clear text UDP protocols. And there's 3 problems with BACNET. I'm actually going to bring up my show notes so you can kind of see how I planned out the episode. And I'm going to kind of talk through what it was with you. Okay, so I'm going to go over here, transition, bring that bad boy over here, bring this guy over there. Okay, so here's the deal, right? So what is BACNET SC? BACNET SC uses WebSockets, which are basically like HTTP endpoints, except for they're bidirectional. So whereas with HTTP, like if I open up this right here is HTTPS, but basically when I want to open up a web page, I do a GET for this URL and it returns all the HTML to me in a post, in a post to my browser. TLS is Transport Layer Security 1.3 plus. It's a secure version of certificating. It basically encrypts the data, right? So at the end of the day, cybersecurity is all about confidentiality, integrity, and availability. For those of you who don't know, I have a master's degree in cybersecurity. I got a bunch of certificates in cybersecurity, and I have a master's in IS. I wrote BACNET APIs. I ran the integration program at Johnson Controls, et cetera, et cetera. So basically what's going to happen is you do a certificate for each device that authenticates that the device actually exists. And it uses a hub spoke methodology. So you have a hub and then all the devices authenticate with the hub, right? And why are we doing BACNET SC, right? Why are they doing BACNET SC? They're primarily they're compensating for the fact that we have utterly failed in training building automation professionals on IT. Because if you understand how to set up VLANs, if you understand how to set up VPNs, if you understand how to set up firewalls, if you understand basic IP routing, etc., you should have no problems setting up a secure version of BACNET IP. It's not difficult. I've done it time and time again. That being said, they are looking at a solution that is going to basically take certificating, take encryption, take all that stuff, mash it all together so that we'll no longer have clear text BACNET. BACNET will not be dependent on BBMDs because you've created a BBMD in the hub. I mean, we're still broadcasting. We're still doing who is I am. It's just all being run through that hub now. And that all sounds well and good until there's a risk with TLS, or there's a risk with a certificating technology or an authorization technology. And then that vulnerable system has to be rolled out in a new firmware, which additionally, in order to roll out new firmware to any controllers, guess what, my friends? You have to update your controllers because most likely if you haven't purchased them in the last 2 years, they are not going to run Secure Connect. So all this backwards compatibility stuff, yeah, it's backwards compatible as long as you're willing to update any controllers that you actually want implementing SC. So supposedly it solves the BACNET routing issues. It just provides an overlay on BACNET routing. It solves the clear text issue. We can do that with VPNs, right? This is the real issue. So I worked in the products organization at Johnson Controls, and here's how this all happens. No shit. This is how it works. GSA or DoD says FIPS, the new FIPS standard, which is the cybersecurity standard, in order for you to install your controls on our site, you're going to go and you're going to be compliant with this FIPS standard. And the account executive serving this like multi-million-dollar company or government agency is like, oh shit, we're going to lose our business. We need something that's FIPS compliant. And they go back to products, and products is like, oh crap, we need to go to BACNET, figure this out. And SC is born. And is SC a good solution for the DoD, for the Pentagon, for things like that? Yeah. Is it a good solution for commercial office building, for a hospital, for a K-12 environment? No. It's overkill. You have IT groups that already have VPNs, they already have certificating, they already have all the technologies in place to secure BACNET, and we're just not using them because we're freaking incompetent as an industry when it comes to IT. Like we can barely explain why we need a subnet to IT people. And so therein lies the rub. Hold on a second, I gotta take a sip of water. So is this the best solution? And you'll get a much more detailed, I'm giving you like super high level here, but the podcast goes into much greater detail. But is this the best solution? The thing about cybersecurity is there's a concept called cybersecurity controls, right? And the number one rule of cybersecurity is when you apply a cybersecurity control, which there's technical controls, administrative controls, and physical controls. When you apply a control, you apply that control to the acceptable level of risk. The risk exposure at a commercial office building is significantly lower than the Pentagon. So the amount of cybersecurity controls we need for a Pentagon or for a DoD or a GSA or, a corporate campus, that level of risk tolerance is much lower. They tolerate much less risk. And because of that, they are going to demand a higher quality of cybersecurity controls. So, that being said, the majority of our buildings do not require that. And we are using a protocol technically to solve technical security issues. It, it's reasonable to bake in encryption and authentication. But is it necessary to create an entirely new protocol stack that we have to explain to IT, that we have to get validated with IT, and that now wraps everything into a single protocol stack so that if there is a vulnerability in any of the technologies in the stack, we have to wait for the entire stack's firmware to be updated? Because I guarantee you they did not use microservices or containerize this stack. So we're going to have to go and wait for them to actually update and roll out the firmware. And the worst thing, the thing that scares the crap out of me, is think about our industry. We put the building automation system in and then we don't touch it for 20 years. How often are you hearing about new hacks and vulnerabilities? It seems like once a month, twice a month. Well, if that's the case and we don't update BACNET SC forever, then we're going to have these people who now they would never have publicly exposed their systems, but they've got this false sense of security because of BACNET SC, and they're publicly exposing their systems. They're sharing their systems, they're sharing their data, and now if we don't keep this protocol up to date, we're going to have vulnerabilities and you're going to be worse off than you were before. Additionally, you'll hear a lot of people quote, well, BACNET's insecure. If I can get into your site and I can plug in my device, I can manipulate your system. And my response to that always is, so you want to create a whole new protocol because you have horrible physical security. So you're telling me because you can't physically secure your building, we need to solve that with software. I mean, that's as like asinine as saying, I'm fat and I eat too much, so Walmart needs to stop selling cookies. I mean, it's got nothing to do with that. It's just, I need to take care of myself. Well, people need to take care of their physical security. The problem that someone's in the building, in your ceiling, connecting to your wires, that is the real issue. So at the end of the day, that's what's going on, JCell. I mean, there's much more to it, but, BBMDs, yeah, you can get rid of them, but here's the thing. You're still going to have broadcasts. You're still going to have them. They're just going to be managed by another device. You said on numerous times commercial buildings are at low risk. Then why is there so much demand for security in commercial building? Who says there's demand, James Smith? And I'm not trying to I hope you all know me by now that if I ask a question, I'm not like, who the F are you? I'm not trying to be like that. I'm just like, legitimately, who's saying there's so much demand? Like, are you seeing that on LinkedIn with, I always ask, whenever someone says there's so much of anything, including myself, like if I say something to all of you, like if I start saying PID stuff and I have a PID training course, obviously I'm biased. So always judge people's biases and what they're trying to lead you in. When I see a lot of people on like LinkedIn and whatnot talking about cybersecurity and risks, I then go and I ask myself, what benefit do they get? Like if it's a consulting firm or if it's an IT firm or if it's a contractor, what benefit do they get? If it's an owner, why are they saying that? Are they just copying what they've heard from a OEM that came in? Yeah, so you've seen a lot of webinars, right? But who's hosting the webinars, James? Who is hosting those? Is it a company that provides cybersecurity solutions? Is it a company that would benefit if a customer needed to implement a cyber secure system? And the reason I say that is just because there's people making noise does not necessarily mean they're, actually a better analogy is just because there's smoke does not mean there's a fire. You could have an overactive smoke machine. You could have a car with a bad muffler. There's or bad combustion. There's a lot of reasons why there could be smoke. And I caution all of you, we have went like so far off topic here, I'm sorry. But I caution all of you as we come into post-COVID and everyone starts reoccupying, everyone and their mom is going to tell you they have an IAQ solution, they have analytics, they have data analysis, they can optimize your systems. And so always ask what's in it for them. And myself included, if I go and I recommend you all take a course, why would I be recommending you? I hope by now we've established kind of a, I'm not going to lead you astray, but still question me. So, okay, could you not use a hard firewall BACNET software? Yeah, so firewall is a part of it, Bruce, but it's not all of it. So the firewall is going to block and regulate traffic, but it's not going to encrypt the data. So it's not going to, we don't really care about confidentiality with our building data, but we do care about integrity. Very few customers that I've dealt with care if you know about what temperature their space is. I've dealt with a few where they do production and the environmental variables in their space are trade secrets because they produce materials. So I encourage you to consider that if you work with those kind of clients. But most of the time, the reason we want to encrypt data is to make sure its integrity is not violated. That way people aren't messing with your set points, etc. At the end of the day, we're creating BACNET SC because people don't know how to manage BBMDs and BDTs. The government wants a more secure system for their sites, and people don't know how to work with IT, so they want to try to embed all this stuff. We're creating a solution for 3 problems, and those are the problems right there. And the cost of this solution in increased cost as far as installing and setup and support, in my opinion, does not justify this solution. What is the response to building operators and owners on the topic of cybersecurity or on BACNET SC? On cybersecurity, I always just ask them, have you done a risk assessment? Have you assessed your risk? What is your risk tolerance? What would it look like if your building went down for a day? How much would that cost you? And then based on that, I can say, how likely is it that your building would go down for a day? And then once I have those 2 numbers, I'm able to say, well, this is the likelihood, and this is the damage you said, then this is how much you should spend on a control against that potential occurrence. It's kind of like being an actuary, right? And doing risk assessments for people for insurance investments. All right, for those of you who stuck in, hey, thanks so much. I know we went like super duper duper off topic. Thank you for going on this little journey with me. I'm going to end it right now. I'm going to go to sleep because I'm getting up at 4:30. And I know I probably won't fall asleep till midnight-ish because that's just the way my body works. It's ridiculous. I wish I could sleep more than a couple hours a night, but I just can't do it. Anywho, it's good to have you all here. I'll see you all on Monday. Thanks a ton, and you all take care.